Hello everyone, as you know, when we release a new model, we always show you where we started with the first prototype and then with the production unit, and the Go is no different. We're going to show you the bare bone version that was the V1, and a lot of things changed to now have the V3 or almost V4 of the Go. So we're going to walk you through every single detail, starting from the back and working our way up. If we look at the first prototype, there was only the motor at the back. There was no brakes inside it. For the production unit, we added the drum brake at the back to be sure that when you slam it, you're not going to flip over the handlebar. It shouldn't happen because of the geometry of the scooter, but still we prefer to have it at the back. Compared to the first prototype, it was in the front. Everything you see on this first prototype is CNC, meaning we cut the metal by hand, by machine, rather than coming out of the mold. So what does that mean? Well, all the plastic is 3D printed, a beautiful job of 3D printing. I'm not able to do that. It's our factory that is able to achieve such a smooth finish with prototypes. And all the metal, again, is CNC. And this is the main difference with the final unit, because when you make a prototype, well, it's easy to CNC with high precision tolerance, but when it's coming out of the mold, all those parts, well, you need to make sure that those tolerances are still the same, and it's very difficult to achieve because when the metal cools down or with the different processes, that's where you get the little imperfection, either scratch or the one part is smaller, the other one is bigger. So it's very hard to achieve the same result as the prototype in the final production unit, and in this case, it's even better. So if we continue, we see again the fender 3D printed on this one, coming out of the mold on this one, but the bracket and the rest is still the same. The fork is a bit larger on the production unit to accommodate for the drum brake inside the motor. The motor is now larger, so the fork needs to be larger as well. The other difference is the easy plug connector. We made a point on all our portfolio to make easy plug connectors on all the latest model at least. So when you want to replace the motor because it broke, or when you want to replace the tire, it's a lot easier because you don't have to go inside the deck to disconnect it. This was added on the production unit and it was not there on the first prototype. Then we have the rear light. The rear light on this one is good, but it's not as bright as the production unit. We were able to push more voltage inside the rear light, and the finish is just beautiful. We also have at the back on the footrest the latch to when you fold the stem to lock it in place. On the prototype and on the V2, this little mechanism was sticking out inside the hole where you grab the scooter usually at the footrest level. On the production unit, we made this handle a bit smaller, so now this allows us to have a flat finish and it just looks more integrated. It's also going to be more resistant to sand, water, dust, as it's more protected now. The other thing is this folding mechanism inside is square, so you really needed to align it perfectly with the top latch on the headset to be able to lock it in place. This is fine, but we know with the Pro that we can achieve a smoother finish, so we basically incorporated the button and inside mechanism of the Pro inside the Go. So now you have a round mechanism, so it's a lot easier to lock into place. You won't have to jiggle it around to hear the locking sound. This scooter, I can lock it, turn and swing it, and it's gonna go on the ground and it's still gonna be attached. And this is the kind of solidity that we're looking for across the whole scooter. Then if we go on the body, this one, the first thing you notice is the kickstand. On the Apollo Go, we wanted the same kickstand as the Pro, meaning a motorcycle kickstand. On this one, it's made out of steel, and you can see it sticking out quite a bit under the deck. We're not able to put it inside the deck for cost reason like we do on the Pro. So we decided to remove that and put a regular kickstand on the Go. Still the most beautiful one we have because it's flat with the body when it's folded, and it's the same color. You know, usually on the Air you have like a little steel kickstand on the side. We wanted something flush for this one, so really happy about it, and it's rock solid as well. So we're able to reduce the cost, reduce the weight, and honestly it looks better like this. If we look at the body itself, this prototype is 48 volt, 10 Ah, and the final production unit is 36 volt, 15 Ah. What does that mean and why we did that? Well, it means that we're able to make a body that is slimmer. You can see the production unit is way slimmer than the first prototype. And it means that I can discharge more from the battery with a 36 volt 15 Ah as I have more capacity than the 48 volt 10 Ah. So what does all of this mean? It means that on acceleration, this one's going to be much better because I have more amperage for the controller for each motor. Because that's the other big difference. On this one, the production unit, we have a dual motor configuration versus the first prototype, which is a single motor version. So this one was able to achieve about 45 kilometers per hour. This one, you're able to achieve the same thing, but way faster as you have both motors. They are both 9-inch tires, and if we move more towards the front, well, again, you see the slimmer body on this one, just looks cleaner. But here, on the first prototype, we added the speaker, again, to have the same functions as the Apollo Pro. So we have the center kickstand, the speaker. We realized that this speaker don't have enough voltage to sound proper. So if I use a horn, it's not loud at all. And we would have been able to boost it more, but we thought for small models like this, you know, what's important for customers is really the cost of the models, you know. So by removing the kickstand, by removing the speaker, by removing the CUB light, we're able to reduce the cost a lot and the weight, and basically offer a dual motor version for the same price. So it was a no-brainer for us. So we have the speaker that we removed. If we go above, we have the charging port. On the production unit, we added a little dent to make it easier to open. It's basically easier to grab the top cap and flip it open, compared to this one that it was flush, so not easy to grab. Then we have the folding mechanism. On this one, we added a rubber strap that goes around the latch, like this. This is going to be present on all our models moving forward. So now you basically have a triple safety protection. You have the orange button that you need to press to open the latch, but you also have the rubbers in case this would fail for some reason or it's not clipped properly. If there's any problems, well, you still have the rubber band holding it down. So that's beautiful. More safety is always welcome. Talking about the folding mechanism in the front, the other thing that you see is obviously the front suspension. On this one, we only had a rear suspension, and as my girlfriend put it, feels like trash. So we needed to have a dual suspension system, and we didn't want to put a big swing arm like we have on the Pro or on the City. This one needs to be low to the ground, and more importantly, lightweight and cheap. And this would not be lightweight or cheap putting a big swing arm like this. So we had to go back to the drawing boards and engineer a new suspension from nothing, basically. We had scooters before with this kind of suspension from the outside, but the travel was minimal, and when you bottom it out, you hear a metal on metal sound. It's not fun, it's not smooth. So inside this one, there's a rubber compression system. So if you bottom out, it's gonna go on the rubber instead of the metal. And the travel of the spring located inside, it's much greater than our previous model that we're utilizing this suspension. And I'm referring to the Apollo Light 2020, you know, the old models. And in the front, the other big difference is how we manufacture the whole fork to accommodate for the suspension. On this one, it is CNC'd aluminum, beautiful fork. We can hide the screws that goes over the wheel shaft. On this one, we utilize steel, so we can make it much thinner. It is stronger, and we can weld it to the system that's going to attach the suspension. So this being welded is going to last a lot longer than having a screw, for example, linking those two mechanisms. So it was the first time we did it, and so far it's outlasting any other front fork we have on our models, on our testing rigs, which is fantastic. And overall, we're really happy with the result, as it looks pretty much the same, but this one, it offers a front suspension, it's stronger, and it's basically the same price, which again, price, I cannot emphasize enough how much of a consideration it was for this model. We want you to have the more value per your buck possible. Then we go up, we see the stem light. So what is different between this stem light and this stem light? This one, we utilize CUB light, which is only a white CUB. CUB lights are LED lights, but much closer to each other, so you don't see the little dot of LEDs. Between the time we did the first prototype and the production unit, we figured out a way to boost the voltage of regular LED, and we found a pretty good supplier that is able to do smooth LED, so we don't need to have a power system that's going to power CUB like this one need, like a dedicated light box. And we can also reduce the cost, and the result is the same, if not better. You know, if I turn both of them on, look at this. This one is a little bit cooler, a bit more blue. This one is white. This one looks better. It fit with the front headlight as well, while this one was a bit off, like this. So we're really happy about the result. And again, for the cost difference, which is massive between the two, this is worth it. If we continue on the stem, there was two other major improvements. The first one is the weld that we're now keeping at the bottom of the stem. This ensures that the scooter lasts 10,000 kilometers, which is the warranty that comes with the scooter. With this one, we didn't put the weld because it was the first prototype, but with repetition, there's a weakness being created there where the bottom folding mechanism part linked to the stem. So we might as well keep the weld. It looks honestly just as clean when you paint over it, and it's a lot stronger. If we continue up, this one here, you can see there's a little opening, and the idea was to have a rubber handle there. So when you fold the scooter and you grab it, you always know where the balancing point is on the stem, because there's that weird thing that when you fold the scooter, you grab it too much in the front, then it leans on one side, grab it at the back, leans on the other side, so you need to figure out the balancing point. And by having something like rubber, when you grab it and you touch it, you know exactly it's there, It didn't last long. It lasted a week and it ripped off. So we're like, okay, it's not worth it, We're just gonna have a clean stem like all our other scooters, not introduce any weakness because we need to dig into the stem to have the handle. The other thing to consider when you add a handle like this, we wanted it to be flush. To be flush, we need to dig inside the stem, we CNC it, and then put the handle. This can only create a weakness inside the stem. So having it flush means that it's gonna last much longer. Then, how do we fix the headset to the stem? On the prototype, we have 4 screws, 2 in the front, 2 in the back. This is how we were doing it on our models previously, and we decided to switch to 6 screws, 4 on each side and 2 at the back. Why? Because when you ride, you're gonna put pressure, side to side as you hit bump and you hold for dear for your life into the handlebar, and back and forth as well. So this is creating a lot of different pressure points on the screws, on the stem, on the headset. So having 6 screws is just better than having 4 screws, and this is what we introduce across all our lineup. So obviously we needed to do it for the Go as well. At the top, we have the quad lock attachment for your phone that was present on the first prototype and is still there on the production unit. On the first prototype, we had a little A logo for the Apollo logo. We decided to remove this because we found with the second prototype that when we were painting over it, it was creating inconsistency for just a small logo like this. So we decided to just leave it flush and not have to deal with this afterwards with QC. We are removing the most amount possible of friction point for our QC team. And there's small design things like this, like the handle, for example, that it's just better to remove it. You need to say no to 1,000 things to have the perfect product, and this is one of them. If we continue, we have the latch. On this one, the latch was square, like I explained before, to fit in the square mechanism at the bottom, and it was very hard to grab. The magnet is strong, holding the latch up, and to grab it, you needed to almost use a little card and flip it open. So we wanted something that was a lot more intuitive and easy. So we added a little bend that you can just pull on it, and then you're gonna lock the scooter in place. So that's pretty cool. There's the little A logo on it, so it's custom, and we like it. For the rest of the handlebar, the other major thing we changed is the actual shape of it. On this one, it's a square. It's pretty clean, but it looks massive. There's a lot of space on each side of the display, the quad lock, and the headset itself is quite thick for no reason. It's empty inside. For this one, we added a chamfer on both sides of the headset from the top, so it looks slimmer when you look at it. And also from the bottom, we added a little angle like this. So instead of being square, it's now at an angle, and this just looks better, it's lighter, and for the same strength. So there was no reason to not do it. And for the rest, the throttle, the turning signal, the brake handle, the display, everything is the same. The little thing we changed during production is the inclination of the brake handle and the throttle. They're now more inclined. So when you ride, this one is at 90 degrees. So you find yourself being like this at resting position, while this one, when it's inclined, it's like this, which is a lot more natural. This is putting less stress on your forearm, on your shoulders, and this is something we implemented across all our models as well, the Air, the City, the Pro, the Go, and it just feels better overall. The last change was a headlight. This one is about twice as bright as the original one, and It's better for obvious reason that I don't need to explain. This scooter overall is a piece of art, and how we started versus where we ended is even more impressive if we consider that this one is 50 pounds and this one is 46 pounds with a bigger battery and a second motor. This is insane. It never happened. Usually you only add this weight to the prototype. So we are very happy about it. We did a video of unboxing the Apollo Go where we revamped our whole experience about how we unbox scooters to make it easier for you. And we're gonna make a video about the setup guide as well. They're both gonna be linked in the description down below. Leave us your comment, what you think about where we started versus where we ended. Maybe what you want to see on the next iteration of the Go. But for now, that's it. Thank you.